In this video, we are going to discuss about the chemical properties of benzene. Roman numeral 1 is electrophilic substitution reactions in benzene. You know what are electrophiles? Electrophiles are electron deficient species. Now, benzene will undergo electrophilic substitution reactions easily, whereas it undergoes nucleophilic substitution reactions with difficulty. Now, why this benzene undergoes electrophilic substitution reactions easily? We know that the benzene ring is rich in electrons because there are 6 pi electrons present inside the benzene ring. So, these electrophiles, which are electron deficient species, can easily come and get attacked or attached to the benzene ring. Whereas nucleophiles we know they are already rich in electrons. So, they will not be easily attracted to benzene ring. So, that is the reason. What is the reason why this benzene can undergo electrophilic substitution reactions easily? Due to the presence of 6 pi electrons. Benzene ring is rich in electrons. So, they undergo electrophilic substitution reactions very easily. So, here we are going to study about the electrophilic substitution reactions in benzene. Now, these electrophilic substitution reactions are given by any compound that contain benzene ring, and we have 5 electrophilic substitution reactions to study. The first one is halogenation, second one is sulfonation, third is nitration, fourth is Friedel-Crafts alkylation, and fifth is Friedel-Crafts acylation. So, in all these 5 reactions, we have an electrophile coming to attack the benzene ring, which is electron rich. So, let us discuss each type of electrophilic substitution reaction. The first one is halogenation. Now, I told you any compound which contain benzene ring can give electrophilic substitution reaction. So, here we are going to study the 5 electrophilic substitution reactions taking benzene as example. Now, what is halogenation? How is it done? Benzene react with halogens in presence of Lewis acid like anhydrous, aluminium chloride or ferric chloride or ferric bromide, and the product formed is haloarenes. So, we get haloarenes as the product of halogenation of benzene. Okay, how is it done? Benzene reacts with halogen in presence of Lewis acid. Lewis acid are electron pair acceptors. Lewis acid like anhydrous aluminium chloride or ferric chloride or ferric bromide. We know that this aluminium chloride, ferric chloride, they are electron deficient species, means they act as Lewis acid. And the name, what is the product formed on halogenation of benzene? Haloarenes. Now, let us write example for this, that is benzene plus halogen, I am taking chlorine, in presence of anhydrous aluminium chloride. Now, we have the electrophile. From chlorine molecule, we have chloronium ion as the electrophile, that I will show after writing this example. So, Cl plus is our electrophile. Cl plus will substitute one hydrogen of benzene and we get the product as chlorobenzene plus substitution. So, one hydrogen is substituted in benzene with chlorine. We have one chlorine from Cl2 which will go as HCl. So, the name of the product is chlorobenzene. Now, I told you the electrophile is chloronium ion. So, let us see how we get the chloronium ion. So, this chlorine molecule in presence of Lewis acid aluminium chloride, what happens is one bond, this bond pair will be taken by aluminium chloride. So, we get Cl plus Al Cl4 minus. So, the Cl plus, this is known as chloronium ion, which acts as our electrophile, and we get chlorobenzene as the product. Okay, so the electrophile coming in halogenation of benzene is halonium ion. If it is chlorination, it is chloronium ion. Now let's try the example with bromine molecule. So next, another example for halogenation is benzene plus bromine in presence of anhydrous ferric bromide. Now here the electrophile is bromonium ion, Br plus, which will substitute one hydrogen from benzene. So we get the product as bromobenzene plus HBr is the byproduct. So this is halogenation reaction of benzene. Now the second electrophilic substitution reaction is sulfonation. Sulfonation. Now in sulfonation the electrophile is sulfonic acid group. Sulfonic acid. Now which is the sulfonic acid group? It is SO3H. This is sulfonic acid. So what is sulfonation? The replacement of a hydrogen atom by a sulfonic acid group in a ring is called sulfonation. Now how is the sulfonation done? It is done by heating benzene with fuming sulfuric acid or oleum. So the reagent used for sulfonation is fuming sulfuric acid or oleum. Oleum formula is H2S2O7. This is oleum. Okay, so here the electrophile is sulfonic acid. Now I am going to write the example, that is benzene plus fuming sulfuric acid, or you can write concentrated sulfuric acid, or oleum also will be given. Now one of the hydrogen atom of the benzene ring will be substituted by SO3H, sulfonic acid group. Now the name of this compound is benzene sulfonic acid. So that is the product formed on sulfonation of benzene. Okay, that is benzene sulfonic acid. So this is our second electrophilic substitution reaction. Now the third electrophilic substitution reaction is nitration. Now in nitration the electrophile is nitronium ion. Nitronium ion is NO2 plus. This is nitronium ion. So that is our electrophile in nitration. Now how is this nitration done? So in nitration, nitro group, that is NO2 group, is introduced into the benzene ring. Now this is done, nitration is done when benzene is treated or heated with a mixture of concentrated nitric acid and concentrated sulfuric acid, which we call as the nitrating mixture. And the nitronium ion is produced by, so here we are using which all acids? Concentrated nitric acid and concentrated sulfuric acid, which is called the nitrating mixture. These are the reagent used. Okay. Now here in case of nitration, the electrophile nitronium ion is produced by the transfer of a proton from sulfuric acid to nitric acid. Okay, so the electrophile is nitronium ion, NO2 plus. Now let's write the equation for the nitration of benzene. The equation is benzene plus concentrated HNO3 plus concentrated H2SO4, heat. Nitronium ion is introduced, or nitro group is introduced to the benzene ring. So we get the product as nitrobenzene is our product. Now, the fourth electrophilic substitution reaction is Friedel-Crafts alkylation reaction. So, number 4. Friedel-Crafts alkylation reaction. Now, from the name itself, alkylation means the electrophile is an alkyl group carrying positive charge. Okay, now let's see how this Friedel-Crafts alkylation is done. Benzene is treated with alkyl halide in presence of anhydrous aluminum chloride. Alkyl group is introduced to the benzene ring. The product formed is alkyl benzene. So the reagent is alkyl halide in presence of anhydrous aluminum chloride. Okay, now we are going to write the example for alkylation reaction. Benzene plus CH3Cl, this is chloromethane, in presence of anhydrous aluminum chloride. Alkyl group is CH3 here, so CH3 group is introduced to the benzene ring plus HCl. Now the name of this compound is toluene or methyl benzene. Now next we have another example, that is benzene plus C2H5Cl. This is ethyl chloride. Now here the alkyl group is ethyl group. Now this reaction takes place in presence of anhydrous aluminum chloride. Again, which group is introduced? Here the ethyl group is introduced to the benzene ring because the alkyl group is ethyl group plus HCl. Okay, so here I told you the electrophile is the alkyl group is our electrophile, that is R plus. Now let's see how we get this R plus as the electrophile. Suppose we are taking CH3Cl. This will combine with AlCl3. Now this bond will be taken by AlCl3, so CH3 will become CH3 plus AlCl4 minus. So methyl carbonium ion, this will be acting as the electrophile in this reaction. Okay, so this is Friedel-Crafts alkylation. The reagent used is alkyl halide in presence of anhydrous aluminum chloride. We get alkyl benzene as the product. Now the last electrophilic substitution reaction is number 5, that is Friedel-Crafts acylation. Friedel-Crafts acylation. Now here it is the introduction of acyl group. Now acyl group is RCO. This is our acyl group. Introduction of RCO, that is acyl group. Okay, now let's see what is Friedel-Crafts acylation reaction. The reaction of benzene with acyl halide or acid anhydride in presence of, we can take either acyl halide or acid anhydride, in presence of anhydrous aluminum chloride. The acyl group is introduced to the benzene ring. Now, what is acyl halide? The general formula of acyl halide is RCOCl. This is RCOCl is acyl chloride. If you write the general formula, it will be RCOX. So you can treat the benzene with acyl halide. The acyl group, RCO group, will be added to the benzene ring. Now, acid anhydride, general formula for acid anhydride is RCO twice O. This is acid anhydride. So, this also has an acyl group in it, RCO group. So, this can also be introduced into the benzene ring. So, you can do this Friedel-Crafts acylation taking acyl halide or acid anhydride. In both the cases, the acyl group is introduced to the benzene ring. That is, the acyl group, RCO group, will substitute hydrogen atom in the benzene ring. Okay, now we are going to write the example. So here we have the electrophile as, the electrophile here is acylium ion. Acylium ion. Okay, so I'll show how that acylium ion is formed. RCO Cl, I am taking acyl chloride plus aluminium chloride. Again, this bond will be taken by aluminium chloride. We get RCO with a positive charge on carbon plus AlCl4 minus. So this acyl or acylium ion will add to benzene. Now let's write example for Friedel-Crafts acylation reaction. Benzene, example, benzene plus RCOCl. I am using acyl halide first. Example for acyl halide is CH3COCl. The name of this acyl halide is acetyl chloride. So the formula of acetyl chloride is CH3COCl. You know the name of acetic acid formula, CH3COOH. So acetyl chloride will be a derivative of acetic acid. So CH3COCl. Now this reaction takes place in presence of anhydrous aluminium chloride. Now heat. Now the product formed is COCH3. Anywhere in the benzene ring you can substitute hydrogen in all the electrophilic substitution reaction, because all the hydrogen atoms in benzene ring are equivalent. So acyl group is this one, CH3CO, RCO. So COCH3, don't write CH3CO. The CO carbon bond is, carbon is forming a bond with the benzene carbon. So C6H5 COCH3 plus HCl. Now the name of this compound is acetophenone. This is the common name. Acetophenone, C6H5 COCH3. Okay, or this is the common name. IUPAC name is, if you give this as carbon 1, so this will be phenyl ethanone. This is the IUPAC name. There are 2 carbons, so ethanone. Now the next example we will write with acid anhydride. Second example, benzene plus, example for acid anhydride is CH3CO twice O. This is called acetic anhydride. So these are the examples for acid halide and acid anhydride. This is acetic anhydride and the acyl group is CH3CO. We have 2 acyl groups here. So only one group will get attached to benzene. Now this reaction also takes place in presence of anhydrous aluminium chloride. Now we can write the product. Product is C6H5 COCH3 plus the byproduct. Only one CH3CO will be attached to benzene. So we have one more CH3CO left, that and this oxygen along with hydrogen will form acetic acid. Now the product of both, when you use acid chloride or acid anhydride, the product is the same, that is our acetophenone. C6H5COCH3, acetophenone or phenyl ethanone is our product. Okay, so these are the 5 electrophilic substitution reactions given by benzene: halogenation, sulfonation, nitration, Friedel-Crafts alkylation and Friedel-Crafts acylation. So electrophilic substitution reactions are over. Now the next chemical property of benzene is addition reactions. So Roman numeral 2. Addition reaction. Now there is only 2 reactions to study. The first one is under vigorous conditions, that is at high temperature of pressure or in the presence of nickel catalyst, hydrogenation of benzene takes place. Means the triple bond, addition of hydrogen takes place. Triple bond, the 3 double bonds break and we get cyclohexane as the product. So let's write the equation. Under addition reaction, first we have addition of hydrogen. So we have benzene plus 3H2 in presence of nickel, heat. The 3 double bonds break and we get cyclohexane as the product. So this can be asked for complete the following reactions. Now next is addition of halogen to benzene. First is addition of hydrogen, second is addition of halogen. Now already we have discussed the addition of halogen to benzene in presence of anhydrous aluminium chloride. Now here we have addition of halogen, that is again we are going to add chlorine in presence of UV light. So under UV light, 3 chlorine molecule add to benzene to produce benzene hexachloride, which is also called gamaxane. So you have to check for the reagent above the arrow. I am going to write the example equation. Benzene plus 3 molecules of chlorine in presence of ultraviolet light at 500 Kelvin. The 3 bonds break and chlorine will add to benzene ring. And the name of this compound is benzene hexachloride, or this is also called gamaxane. So these are the 2 addition reactions given by benzene. Now the third chemical property of benzene is combustion. So Roman numeral 3. Combustion of benzene. You know that the combustion of any hydrocarbon will give carbon dioxide and water as the product. Here also we are getting the product as carbon dioxide and water. So here on combustion you get a sooty flame. Sooty flame. Okay, so when heated in air, benzene burns with a sooty flame producing carbon dioxide and water. Now this is any compound, if it contains benzene ring, when you heat it, you get a sooty flame. It burns with a sooty flame. Any compound, any organic compound, if it is aromatic, aromatic means if it contains benzene ring, will burn with a sooty flame. So you are doing this as a test for the practical, that is whether the compound given is aromatic or aliphatic. Aromatic compound means they contain benzene ring. So when you heat that compound, you get to see a sooty flame. And if it is aliphatic compound, you will not get any sooty flame, you get a non-sooty flame. So aromatic compounds will burn with a sooty flame. So I am going to write the equation with benzene plus 15 by 2 O2 gives 6 CO2, carbon dioxide plus 3 H2O. So this is the equation for the combustion reaction of benzene. Benzene will undergo combustion and we get a sooty flame with the liberation of water and carbon dioxide gas. So these are the 3 main chemical properties of benzene. Electrophilic substitution reaction, second is addition reaction, and third is the combustion reaction. So we have completed the chemical properties of benzene. Thank you.